Okay. Simple harmonic motion. Oh, I found the secret to making sure it always works. I found the secret to making sure this pen always works.
What?
The secret is you must turn that on first before this. Then it will always work.
Well, if it's all just a coincidence.
It could be, but I have a feeling it's not. Now, we could test that out later if I tried to turn this on first before that.
Sorry.
What, Leslie? I want to start. No.
Which one?
The one that says a particle of mass 1 kg. That one. Okay. I'll do number 1. A particle of mass 1 kg rests on a smooth horizontal table which stands between two vertical walls 6 meters apart. So you have a wall here, and they're 6 meters apart. The particle is joined to each wall by means of a horizontal elastic strings. Both strings have natural length 1 and constant 2. So both strings are length 1 and constant 2. The particle is released from rest a point 2 meters from the wall. Show that I will perform simple harmonic motion and find the periodic time. So it's 6 meters wide, and the particle starts its life 2 meters from this wall.
You see that in the left?
Well, he doesn't actually, which is a good point that I was going to say. He doesn't. In fact, it doesn't matter.
Okay.
No problem. And it starts here 4 meters.
No.
Okay?
The third page.
Come on, Hussein. Come on.
My bad, I know, sorry.
Now, the natural length here, we're told is 1. And the natural length here, we're told is 1. And the constant here is 2. And the constant here is 2. Now, they made our life easy for us. Where would the particle rest so that the force would be balanced?
In the middle.
In the middle. Why the middle?
Because it's balanced.
Yeah, but why? Because each string is identical.
Same.
So the forces will be the same in the middle. Okay? So this place here is called the equilibrium position. Now let me call this distance here from the equilibrium, I'll call that x. And at the beginning it would be 1. X equals 1 at the beginning.
Why?
Because it's 3 in the middle.
Okay.
Yes. Now, what's the force to the left? The force to the left
Okay.
would be 2
2 minus 1.
times the extension. What's the extension?
2.
Well, that's a little bit tricky. If here to here is x, then how far is here to here?
It's 3 minus x.
3 minus x. Because the total here is 3.
3.
So here to here is 3 minus x. Oops. 3 minus x. Okay. Now, if the natural length is 1, how big is the extension? Well, it'd be 3 minus x
2 minus x.
minus 1. Yeah, which is 2 minus x. Which equals 2 minus x and then multiply by 2. 4 minus 2x.
Yeah.
Now the force to the right, in this case here, how big is this string? Well, it'd be 3, from here to here is 3,
Okay.
plus x. And the constant is 2, and it's 3 plus x, and then what's the natural length? 1. So it'll be 2 plus x. Yeah?
What's 3 plus x?
Why 3 plus x? Here to here is 3,
Yeah.
and then here to here is x,
Oh, yeah.
and then minus 1. So that's 2 plus x, which is going to be 4 plus 2x. Now the total force equals the force to the right
Number.
minus the force to the left, which equals 2x,
4x.
4x.
Yes, but it's 0.
No, it's not. 4x.
Oh, yeah.
So remember, to show its simple harmonic motion, you need to show that the force equals a constant times a distance. And then it's Hooke's law.
So half.
No, we just leave it for that part.
One.
Huh?
Oh.
Now, if you remember, if you want to think about it this way, this is the force to the right, so it's positive, but to the left it will be negative. So sometimes you need a sign here, sometimes you don't, but I won't care about the sign so much right now. We also have another formula for force. It equals m omega squared times x or s or whatever letter you're using. And we know that this should equal 4x. So that means m omega squared equals 4. But what does m equal? 1. So that means omega squared equals 4. So what does omega equal? 2. So the time, remember the formula for time?
Yeah,
2
pi
pi
omega.
over omega. So that would be
Pi.
2 pi over 2, so that'd be pi.
Okay.
And that's really it.
What is that?
Can you go up, please?
I could. How far, Jing Dong?
Oh, yeah, that's.
To the beginning?
Yes.
Oh, Jing Dong.
This is 7.
Yes.
F equal m omega squared r.
Yeah.
Okay, from where?
Or x or s or whatever one. I believe I gave you that formula last time.
Yeah.
Yeah. I'm sorry, I realise you have lots of formulas for this topic.
Yeah, can you go down?
Well, Jing Dong's right in this part.
Yes, right.
Students, should we know all of them?
Yeah. Sorry, man.
Okay.
Go down.
Yeah.
How far? To the end?
Yes.
That's the end.
No problem, it was an x or r. What's the matter?
No, it's just a letter that represents length, position, distance.
Peter Stephen.
Yes.
What's SPC?
SPC? No. SEC.
SEC.
Seconds.
Okay.
And you want the time, right?
Yeah. There's more to the question, but I think this is enough because the last thing they want is this velocity. But you just use the formula for v. So you could say v
M
equals.
squared over r.
No, that's for circular. You need the other one. It's v squared equals omega squared.
V squared omega multiplied a.
There's
no,
one
that's
like
v
that.
max.
No.
Yeah, no, I want the other one. V squared equals omega squared.
Bracket a squared minus x squared.
Yeah, that's it. And in this case, they want the velocity in the middle. So the x for the middle. You have the omega. You have x. Listen, you have the omega. Yes.
Yeah.
You can find. You know what the x is. It's the middle. So the only thing you need to know for that formula is the a. What's the a here? Remember, a is maximum.
X max.
So what's that here? The maximum x is 1, is it? Because here to here, no. Yeah, here to here is 3. So here to here is 2.
Okay.
So at the beginning, how much is it? 1.
Huh?
It's 1 at the beginning. Look. Here to here is 2.
Okay.
Yeah.
Here to here is 3.
Three.
So here to here,
1.
1. And that's the maximum because what happens as time goes on? Gets smaller. Bigger. Smaller, you know, like this. That the a is 1. So you have a, you have omega. Well, what else do you need? I think that's everything. If you have a and omega, you can find everything now. Yes. You just need to show the force is equal to a constant times the position. Yeah. It doesn't matter what the value is. Just that force equals a constant by a position means that it'll be simple harmonic motion.
What is x?
Huh?
X.
X here is the distance from the center.
No, for the to get the velocity.
Oh, 0, because it'll be in the middle.
Mr. Stephen.
Yes.
SHM means left equal right.
No.
So v equal to
Somebody tell him SHM, please.
what's it?
Simple harmonic motion.
Simple harmonic motion. It's the name of the chapter. SHM for short. Simple. Do you want to write it down? Simple.
The only the same.
Harmonic. Harmonic.
Is it 7?
Motion. M-O-T-I-O-N.
N-O-T-M-O-T-L-O-M. Sorry.
Hussein, please tell him.
M-O-T-I-O-N.
Okay, thank you.
Thank you. Yes.
Sorry. The other question all the same time.
Yeah, same idea.
Okay, what's here number 9? It's 2 pi.
Number 9.
Yeah.
There's no number.
And the answer. Just see. Look at the answer. 2 pi root hs over g. What's hs?
2 pi. Which question?
Number 9.
Ah, no. I don't have all the questions here. I only gave you 1 to 5. So ignore the other answers. I felt 5 questions was enough on this.
Yeah.
I mean, I could have stuck the rest on the back, but if you want more, I can give you more.
5 is enough.
5 is enough, I think.
Yeah, just do as a list will be better.
What?
No, less would be a problem. Okay. We start the next topic?
Can I say something? Like an announcement?
Be quick.
Tomorrow physics on 12. We meet at canteen.
Okay.
Okay.
I remember.
Yeah.
You remember?
Just come to canteen. You'll find us there. Okay.
Okay.
Alright.
Are you ready for the new lesson?
Yeah.
Yes? Okay.
Will be easier.
Oh, that depends what you mean by easy. Easy for you or easy for me? Whoever that.
For you, everything's easy.
I wouldn't say everything is easy for me.
Yeah, sure. Everything's easy. You will give us the paper?
Yeah, I will, yeah. Okay. The simple... That is English over there, isn't it, Ted?
Yes. Why you lie?
I don't know. I don't know if I believe you. Are you telling me the truth? Exactly.
What is the harmonics missing?
Oh, sorry. I'm not... Sorry. Ted distracted me. Right. The simple pendulum. Now, who knows what a pendulum is?
Pendulum, it's not the
No, not that. Do we
Is the
know?
man who invent or they create a formula or something?
No. I think you might think...
It's not the system. Is the system?
What system?
Is it that system? You hang something from a height and like you give the
I have,
acceleration.
I have a pendulum right here. Here's my pendulum. I made it this morning. Here it is here.
I told you that's going this way.
No, you said this way.
No,
I touched my
said this
yo-yo.
way.
Okay. This is a simple pendulum.
Oh.
Like an o'clock.
Like on a clock.
Like hypnotize.
I hate
Hypnotist.
this class.
Yes? So this is a pendulum.
Yeah, parody.
Huh?
They will come from the Italian science.
Oh, Galileo. Galileo. Correct. Very good. Galileo's the first one to look at these. Do you know Galileo?
Yeah.
You know Galileo. Who knows? Who doesn't know Galileo? You don't? You know Galileo? Why is Galileo famous?
Because
Because he invented the yo-yo.
he found the clock.
That's one thing, but another thing that got him into trouble. Yeah. This got him into trouble. Why?
He said
Galileo said
the world is
the sun is the center and not...
no, not turning around to
Heavenly. From Poland.
Who?
Yeah.
Are you
From
sure?
Poland. He was killed by the fire.
Oh, okay. Well, Galileo said the sun is the center
Okay.
and the church put him into prison. Do you know this story?
yeah,
Yeah.
then killed him.
Did they kill him in the end? I thought he was just
No,
I thought he was just house arrested.
no, executed.
Was he?
Because they said just take back the thing because it's against our
Yes.
Bible and things. and
Whatever, let's
said
go
no.
to class.
It's important to know
Hey
history.
man, that's more important than this.
Yeah.
Okay, just speak.
So anyways, Galileo was the first one to look at the solar system and to say that the sun is the center. Like what we did last week. Remember the earth going around the sun?
Yeah.
He also looked at pendulums. And he also counted how long it takes to do one cycle. Now, if you look at this, what type of movement is this? How would you describe the movement? Like it's going this way and this
Like-
way and this way and this way. What's the name of this movement? No, come on, I did it today. Jing Dong asked me the question.
Simple harmonic motion.
Simple harmonic motion. You know,
Yeah.
it goes like a spring. Think of a spring. You pull a spring, what does it do? It goes like this.
Yeah.
Yeah.
It's the same for this.
Mr. Stephen, don't tell me you have to calculate the sine and cosine.
Yeah. Right? Simple harmonic motion. So let's calculate it for this. So,
I hate
no you don't.
this.
No you don't. Now, you all need your calculator. Before we begin, I want you all in radian mode to calculate sine 0.1, sine 0.05, and sine 0.01.
0.1 is 0.09.
0.0999.
9. And the other one is 0.0499.
Okay?
The other one is 9 point.
And the last one,
And the last one is 9.910.
99,
Yeah. 10.
like this.
No. 9.9.
Hang on. What's the digits? 0.00.
No, it's 9.9 power 10 minus 3.
Oh, okay, which is 0.009.
9.
Now look at this number here, 0.1. And what's this number approximately? 0.1.
0.1.
And this one's approximately 0.05.
9.
And this one's approximately
Yeah, the same,
0.01.
right?
Yeah, it's about the same. So the first result we have is that sine theta is approximately theta if two things. First, it's in radians, and secondly, if it's small. So provided that you have that sine theta approximately theta. Yes, that's important to note. Yes.
X
Where? Here?
between the two theta.
Oh, this.
Yeah.
The symbol means approximately.
Oh, here.
Or roughly.
Roughly, yeah.
How to use calculator to get the 0.099?
Is your Ted? Can you check if his calculator's in radian mode?
Just bring it to here. Press shift.
I get a different.
Yeah, because your calculator's probably in degree mode.
Can I do it?
No, you let them figure it out. It's better if they figure it out themselves. Do you have it in radian mode? Yeah. It was in degree, yes. Are you happy now, Jingdong?
What?
Are you happy?
Maybe.
Shall I continue?
Okay, you can continue.
I can continue? Right, did you all write this down?
Yeah.
Okay. So now let's look at the diagram for it. Okay, so here's our pendulum. And its mass m. Angle here, I call it theta. Like this. Now there's forces on it. There's two forces on it.
It's not like in a kinetic energy, the ball is going and coming.
Yes, we did that in kinetic energy, yeah. What's this force here?
Oh.
Yeah, what's the value of it?
mg.
Mg. And then what's this force here?
R.
Not or tension, T.
Why?
It's a string. Okay?
Yeah.
Now, I want to break this tension up into two forces. I want to break this gravity force into two. So I'll say one this way, and then one this way. Now, if this angle here is theta, then this one here is theta. So is this going to be cos or sine?
Cos.
Mg cos theta, very good. And this one here, mg sine theta. Okay. Now, T must equal what here? Mustafa, get off the phone.
MG cos.
Mg cos. They cancel. Why do they cancel?
How did you know that's sine and that one's sine?
You were playing on your phone when I was explaining this, so I'm not going to repeat myself. No, sorry, that's your problem now. So why does T equal mg cos? No, you can tell him later when I'm not talking. Why does T equal mg cos?
Because
They cancel this way. But they don't cancel this way because it moves this way.
Yeah.
So if I was to draw this again, here's the ball, and it has a force this way, and the force is mg sine theta. Yes? And actually, I'll make a minus because it's going to the left. Now, using our result at the beginning, what does this approximately equal?
Sine theta.
Minus mg theta. Okay? Now, if you think back to radians in trigonometry, this distance here, let's call it x. Does anybody remember how to calculate x? Yeah, very good. What is it? L theta. So what does that mean theta is equal to? X over L. So if I go down here, I can say this equals minus mg x over L. Okay? Now what's happening to the ball? It's going like this. Now is it travelling in a straight line? No, but it's nearly a straight line. Okay, listen again. It's nearly straight. Nearly linear. Okay, so let's just say it is linear. What type of motion is this? Simple harmonic motion. And what's the formula for force for simple harmonic motion? Minus m omega squared or in this case we'll use x. And that should equal what?
mgx over
Minus mgx over L. Now I can cancel the x's, I can cancel the m's, I can cancel the minuses, and I can square root both sides, and I get omega equals root
g over
G over L. So what's the time?
time equal 2 by
Time
over
to value.
2 by over
Root
root
G over L. So that means time equals 2 pi root L over G. Now you'll definitely have to write all this down.
Can you go up now?
Yes.
So this is the new formula?
As a new formula. How far up do you need me to go? To the diagram?
Yeah, that's it.
Here. Okay.
Can you tell me what how is that sine?
Hussein was offering to tell you.
That's not really.
Apparently that's why.
That's not really a good explanation. Why? Which one's cosine? Mustafa?
That's on the right cosine.
Cosine is always the side that touches theta, and sine is always the opposite side. So cos always goes on the side that touches the theta. Always. Tell me when you're ready to go down.
Not yet.
Not yet.
Yeah, That's T is time.
Yes. No, that T is tension actually.
You said 10
No, he said time.
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 Why is the x equal elevation?
This is from trigonometry. We have a rule in trigonometry that tells us
R equal
R equals R theta. Yeah.
That's it.
Yeah, that's what I used. I used the rule X. Sorry.
Okay, you change the sign from R to X.
Oh yeah, yeah. In the trigonometry we used or, but here I'm using X. So yeah, it's like X equals or. No, sorry. Here R equals L. The radius is the length.
Okay.
And we have a formula that says the arc length equals R times theta, which will be L times theta for us. And I call the arc length X. Will I go down?
Yeah.
Yes.
So see here, it's nearly linear. It's nearly a straight line. It's like a spring. Yes.
For the mg cosine theta, if you were to draw a triangle this way, you can get this result. But if you draw a triangle in this way,
No, you should
then
only get
this
one
would be a
result. No,
sine.
no, 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 you should only get one result.
So
If you're doing your triangle wrong,
yeah.
just do the triangle that way, yes.
So you have to follow this way.
Yes, because I want, yes, what are you telling me?
Because if you draw a line here, there is also a right angle here. So this will be the sine theta. And
But you can't draw it this way.
why?
Well, the force is going down, right? So you can't draw this perpendicular to this because this will be zero.
Why do you
No, 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 no. Listen carefully. If I have a force like this,
Yeah.
and if you say, okay, let me break this force into a piece this way,
Yeah.
and like a piece what, this way? No, 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 you're drawing the triangle wrong. Just do it the way I did it. That's the only way to do it.
But why is that so?
Hang on, just a second. Do you want me to go down, Mustafa?
No, that's fine. There's no.
Okay. No, you can't draw the triangle like this.
But it sounds.
No, it's completely. Look, here it is here. It's going down like this, okay? And you have it's moving this way.
Yeah.
So you should draw the forces that way because it's going that way. You can't draw it. What way are you drawing it? Like this way or something?
It's just the same direction. Just that I put a triangle. I put a line here to make a triangle.
No, don't do this. Don't do
Why
this.
is it?
Just do it my way. You're making your life difficult. Don't make your life difficult, please. Please. Just do it my way. You're putting the line where? You're putting it here?
Yeah,
You're
just
putting
a
it
line.
this way?
Yeah, this way.
No, because
from here to here.
from here to here. You get the door, please. Hey. Right, come back, come back, come back, come back, come back. Right, which way are you putting it?
From here to here.
From here to here? No, 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 because it's still the same problem.
Why?
You don't want to draw it perpendicular to this,
Why?
because it'll be zero.
0.
Yeah, yeah, because look, if I have a force this way, and I draw part of it this way, and I say, how big is this? It's always going to be zero. Because the whole...
Because you put this line here because there's a force here.
Yeah, 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 yeah. This one here because that one's there.
So you don't just anyhow.
You don't just draw any triangle. Okay? Happy?
Yeah.
Okay, are we happy with this? Yes? Okay. Right, so we have our equation here, t equals 2 pi root L over G. Okay. So, what things do we know, well, what things can we know about this straight away? What things do we know automatically?
2 pi
Well, yeah, 2 pi for sure.
and G.
Yeah, Now let's pretend for a moment we don't know G. It's something we want to calculate. So what other things could we know? We could know L, and we could know T. So I could use this formula to find G. Very good. Okay, but I have to rearrange it first. So what do you think I should do to rearrange it? What don't I like here about it? The root, yeah. So what should I do first?
Square all of them.
Yeah, square all of them. So what do I get?
T square.
T squared.
T squared equals
4
4
I squared.
L over G.
L over G. Okay. Now there's still a tiny problem. What's that? What am I looking for? The G. And where is the G? It's down below here. So what should I do next?
So G equals 4
Switch the places with
Yeah,
T
swap it with the T squared. So G equals
4
4
pi
pi squared over T squared
and the L.
times the L. Now, you don't really need to remember this, okay? You just need to remember this one. But you need to know how to go from here to here.
But the G always is 9.81.
Yeah, exactly. So, it doesn't matter what the L and the T here for the pendulum is. You should always get 9.81 here. So I need two things. I really hope somebody has a ruler. Does anybody have a ruler? Good.
Okay,
And a stopwatch, please.
Yeah, stopwatch.
Okay. Now, Ted. You go. No, go ahead. You measure this for me. Tell me what the L is. And who wants to be in charge of the stopwatch? No. You don't want to take the responsibility for this? You can do it? Okay. Now there was a couple of things we said must be true for this. What was the thing at the start we said must be true? Something we assumed at the start.
maybe it will be linear.
Yeah, that's one thing. It's linear. What else? Something about the angle.
Yeah, the same it was in radians and simple.
No, not
Well,
quite
we
that.
said sine theta is equal to theta.
Yeah, yeah, but why are we allowed to say this? It's only a certain case.
In radians.
Yeah, and the second
Small.
thing, first it's radians and it's small. So when I swing the pendulum, can I hold it out very high? No, I have to hold it, the bottom. Okay? You don't have to be too accurate. What did you get?
Roughly it's about 70.
Roughly 70.
Yeah.
Okay, good, good. Alright, can I go to the next page?
Yeah.
Yes? Okay. Yes.
You're not going to do anything with the...
Oh, I'll do it now in a second. I'll just write down my information. So L equals roughly 0.7. Now, the T here, what does that represent?
Time.
The time for what though?
period.
Yeah, so if the pendulum starts here, what marks the end of 1T?
It ends there.
Yeah, when it gets back to the start.
Yeah.
So look, this is 1.
Yeah.
Okay.
1 circle.
1 cycle, very good. Now, do you think we should let it run once and time how long it takes, or do we have a better idea? Like, should I just let it go and time it once?
No, we can
No,
try
well that would be fine, but how could we improve on this?
10 times and
10 times, yeah, why?
divided by 10 to get more.
Yeah, why, but why is that more accurate?
I don't know, that's what we did
That's
last
what you
year.
did, yeah. If I let this go 10 times and then divide my answer by 10, why is that better?
More accurate.
Yeah, yeah, but why?
It's not the same
more
as
accurate.
if you make it as
Yes, it's more accurate, but why?
Less error chance.
That's the same thing as more accurate.
Yes.
But why?
Get the average.
Yeah, but how does that help make it more accurate?
Because you have to manipulate data and you get the average.
Yeah, good, but how does that make it more accurate? I
Like
don't think.
each time you have chance to like.
Or let me put it this way. What is the error coming from?
for the time watch.
Yeah, for the stopwatch, right?
Yeah.
Because if I say go and you hit start, will that be perfect?
No.
No. So if I do it 10 times, what happens? You're dividing that error by 10. Do you understand?
How
So,
about-
and the same happens at the end when you say stop.
yeah.
You divide that error by 10 because you're only making that mistake 1 per 10 cycles. Yes?
Mm-hmm.
Now that's a good thing about it, but what's a bad thing about doing it 10 times?
Because if you it was in a small,
Yeah,
distance,
yeah.
maybe it will stop before you do the things.
Very good. If you do it 10 times, what could happen?
Maybe
It could
stop.
stop. Yeah, why is it slowing down? Friction, very good. So the problem is this, if we do it too short, we have an error with the stop-start. And if we do it too long, we have an error with the friction.
Do 5.
So I think 5 or 10. Shall we try for 10? Because then it's easy to divide by 10. Right? So you're doing the stopwatch?
Yeah.
Yes, okay. Are you ready now? We'll try and get it perfect, okay? Alright. Now we'll have to count 10. Okay? You ready? Actually, it's probably better if you say start.
So I'm gonna say start, and I'm gonna say.
Yes, yes. Well, it's going to stop automatically at 10. So I'll say stop, you say start.
Alright.
You got it?
Alright, I say start.
You say start, I say stop. Alright, okay.
Alright. Start.
So that's 1, 2, this is looking bad. 3, 4, 5, 6, 7, 8, 9, stop. What did you get?
16.9.
16.9. So the time for 10?
16.9. Why we don't
16.9 seconds.
why we don't make the time small t? Because we make it different.
Yeah, usually we use big T to mean one cycle and small t for less than this. But you can use small t, that's fine. So this is for 10t.
So divide by 10.
Yeah, divide by 10. So 10t equals this. So t equals 1.69 seconds. So g should equal, what did we say the formula was? 4 pi squared root.
No, we cancel the
Oh, sorry, we did, didn't we?
G. No.
That was it.
L.
Hang on, we'll just go back up.
Over T.
4 pi squared over t squared L.
L over T squared. Yeah.
Okay, so you should have 4 times 3.1415 squared all over 1.69 squared times 0.7. Now we can see how good and bad we were.
9.66.
9 point,
66, 67.
let's be generous and round it up to 7, huh?
Yeah.
No.
67.
We'll say 7 so it makes
Oh,
it look
yeah,
better,
yeah.
yeah? So we got 9.7 meters per second squared, but what's the true value? 9.8 meters per second squared.
So our is correct.
Almost perfect. So the error was
What the unit of the G?
meters per second squared.
The same unit for the acceleration.
Yeah, same unit. 0.1 meters per second squared. Okay? Now we should make this a percentage to see. So can you again take out your calculator? 0.1 over 9.8 times 100 over 1. So this is the percentage error.
Small.
1.1%.
Oh, not bad.
What?
1 point,
1.02%.
so 1% about, yeah. 1.02%. Not bad for a little bit of string and blue tack, huh? Not too bad. Okay, now I just go back to the formula here for a second. So how can we improve this further? So we have G equals 4 pi squared over T squared times L. Okay? Just look at it like this for a moment. What I'll do actually, I'm going to take the G back down and the T back up here. So T squared over G. Okay. So let Y equal to T squared and let X equal to L. And let's say let M, now this isn't mass, okay? This is slope. Equal 4 pi squared over G. So that equation up the top becomes Y equals mx. Yes? Because t squared I'm calling y, L I'm calling x, and this number in the front I'm calling m.
So where's the L? You have to have
How do you
the L
get
there.
an M?
Yeah, okay.
Yeah? What's that, Jing Dong?
How do you get an M?
How did I get m? Or why am I making m this?
Yeah.
Yeah, because what I'm going to say now is we're going to do this experiment many, many times, but we're going to change the t and the L. So if I was to change, or if you think about it like this, I'm going to do the experiment many times and these are going to change. So this is like a y and this is like an x. It's like
Math.
like in the maths class, yeah.
Math class.
But this here, look at this. This is constant, isn't it? I mean, does 4 ever change? Does 4 ever change?
Yeah, okay.
No.
We make that y equal
MMX, yeah, basically,
y,
yeah.
if we ask for the y, what you do with that y?
Well, we'll get to that in a second now. Just to finish here, does 4 ever change? No. Does pi squared ever change? No. Does g ever change?
Yes.
Well, if you're in the same place, it shouldn't change. Okay? So this here is like a constant in the front. So this here and this here can change. So that makes me think I should write it like this, y equals mx plus c.
Okay.
Now what you do is you do the experiment many times. So for example, what was the L for us? 0.7.
Yeah.
And what was the time? 1.69. Now maybe if I repeat the experiment and make the L different, the t will be different. Will it be bigger or smaller? Let's have a look. If the L gets bigger, what happens to the t?
Bigger.
It gets bigger. So for example, maybe, I don't know, something like 1.8 or something like this. So, if you were to put this on a graph, and if I was to put, what did I say, the x was L here, and if I was to put t squared here,
And then you will get the slope from the graph.
very good, then you'll get the slope from the graph. Here's all my experiments. So maybe this is my first experiment, where I got 0.7 and then 1.69 squared. And then I do the experiment again, I get another point.
So you will take the x with the y,
Divide.
divide by x with the y in the first.
Yeah, so you can find the slope of this line from your graph. And you can call the slope equal to m. And once you have the slope, you can work g out because the slope will equal this. So you have 4 pi squared over g. So m equals 4 pi squared over g. So I can say g equals 4 pi squared over m. So in other words, it equals 4 pi squared over
Slope.
the slope.
Okay, I mean, if in one of the questions he asked for g,
Yeah.
and we used to take that y equal mx, how are we gonna change between g and t? And y.
Oh, how do you switch between the two? Well, what would he give you?
Huh?
What do you mean? What does he give you?
He give me everything, and he won the g.
Okay. I don't think that would really happen. They wouldn't give you everything to ask the G. You see, in the exam, it wouldn't quite be as straightforward as this. Like, for example, I can go back to this page, but let me just go to the next page for a moment. In the exam, they make it more difficult for you. They don't put the ball at the end of a string, they put it at the end of a spring. Yes. So you have the tension force here, but the tension force is what type of force?
K x minus.
Yeah, what's the name of it? Yeah, simple harmonic motion. So your life is made more difficult.
So you mean the 2 lesson and 1 lesson?
What I mean is this
2
lesson.
lesson and 1 lesson.
Yes. Yeah. 2 lessons in 1 question. Yeah. Now we would need stuff like this when we do the experiments. We need to learn how to calculate things like G. So it's more beneficial for us for learning how to do experiments. Talking about error, you see up here? Error, and then talking about what graph to make. Just one final thing about the graph here. Will all these points lie on a perfect straight line? No.
Why? No, it's going the same way.
Maybe they'll look a bit more like this. Why won't they be on a perfectly straight line?
It's square, that's why. Is it?
No, not because of that.
No,
Why?
it happened on a mistake or error.
Error, very good. This is off the line because of your error. So,
But in the end, you're gonna but just take 2 points.
exactly. So, what do you do in the end?
No matter what any point you are taking, is that it?
Yeah, if you look here, imagine this is our data. This isn't really a straight line. But what you're expected to do is draw this line here,
And take which is in the straight line.
the best, yeah, which is the best straight line you can make. So the name of this line is called best fit. Now, do you all know the computer program Excel?
Yeah.
Yes? Do you all know Excel? You sure? Microsoft Excel, yeah? You know the computer program, and the program has all the tables.
Yeah.
And like here is A, B, C, D, and Excel, yes.
Yeah, the most teacher use it for the grade.
Huh?
The most teacher use it for the grade.
Yeah. Now, Excel has a very nice feature. If you put your points into Excel, it can make this graph for you, and it will draw the best line for you. Yes, so for the experiments in January, we will use Excel to handle our data. Yes?
It's the
Data is the numbers you collected from the experiment. Okay. Any questions with this? No? All happy? Okay. Now what I'm going to do is, I have a worksheet here. I'll do the first question as an example for you,
And we are doing the rest.
and then you can try the rest. Do you need me to go back to the question? How far back? Like here? Or further?
Yeah, that's it.
Just to here? Okay. Right. Yes. Question? You can have to. No problem. Yes. Go ahead. You can have one square if you want. I'll open it when you come back. You have one, you have one, you have one.
But Mr. Stephen, there are small question for answer for that big answer.
Hmm?
There are small short question for this old answer.
Yeah, well you see, what I did there was how to do these questions plus an experiment of how to calculate G. So really all you need from this for today's worksheet is just the formula for T squared.
Okay.
I'll give you an example with the first one, okay?
So like you want me to just no? Yeah, no problem. Yeah. Sure. Yes. This is just
Can I do the first one? Did you write this down?
yeah.
Yes? No, you don't need this.
What?
You don't need this. Did you write down this part here? This one? Yes? Okay. I'll give you the first one as an example. Okay, can you all look at the first one there?
This is the first one.
Yeah. A simple pendulum consists of a particle of mass 2 kg attached to one end of a light inelastic string of length 50 centimeters, the other end being fixed. Find the periodic time. Find the tension in the string when the string makes an angle of 8 degrees 6 minutes at the vertical. If this is the moment when it comes to instantaneous rest. Okay. So the first thing, the time. So here, what's L?
0.5 meters.
0.5. So the formula for T squared, or T, T is 2 pi
2 pi
root L over G,
G over L. Yeah, okay.
which equals 6.2830 square root 0.5 over 9.8. Can you calculate this for me, please?
It's 1.42.
1.42?
Yeah. 7.
Yeah,
Is it right?
yeah, it was 419 at the back, so we'll say 42 is fine. Is that okay, Ted?
Yes.
Yes? Okay. And then the second part,
It's only right.
yes?
1.4.
The second part is they want the tension in the string when the angle is 8 degrees. So if you remember from my diagram, here is mg. What's m here? 2.
Okay.
And what's g? 9.8. So do 2 times 9.8. What's that? 19.6?
6, yeah.
So there's 19.6 newtons force this way. And you have your 2 parts here and here.
So the right will be the same.
Yeah, this is the one we want. So this is mg 19.6 cos. Now they use minutes here. We don't really use minutes for the course. So we'll just use 8 degrees, okay? It's actually 8.1 degrees if you want to be exact.
It's 1T. That's the tension.
This is, yeah, it's the tension. So can you calculate that, please?
So this will be
Should be something like 18 newtons.
19.
Okay. Oh, okay, bigger than I thought. Yeah, 19.4. 19.4 newtons. Are you okay with that? Yes. So there's only 2 things really for this worksheet. The first one is this formula. And the second thing you need to be able to do is draw the graph, the diagram for the pendulum. And we always use what here?
the theta.
What type of angle?
No, it's cos.
What?
Right.
Radians.
So in the calculator it should be right.
Did you put it in radian mode or degree mode? Or you just got the answer from the back?
No, I found it on degree mode.
Okay, well look, it doesn't matter. This is in degrees, and if your calculator is in degree mode, that's fine. But what you really should do, to be proper about it,
Radian is minus 4.7.
wait, I'm explaining. If you really want to be proper about it, you must change the angle into radians. Because we only deal with radians here for this. Now it's fine if you want to leave it as degrees and put your calculator in degrees mode, but I don't like this. We should really change it into radians. Do you remember how to change it into radians? 8.1 multiplied by pi over 180.
Yeah.
What's that, please?
What's that?
Yeah, what is that? Calculated.
What are you calculating?
8.1 degrees in radians.
What is that?
Yeah.
141.
Thank you, Albert. 0.141. So that's the angle in radians.
Just a minute, the pi is not 180?
No, you said this last time. The pi is 3.14. That never changes.
2 pi is 180.
0.43.
No. Pi is just this. What are you getting for me, Jingdong?
0.43.
No, I think this one is right. Well,
This is right?
Yeah, 0.14.
Did you type this in, Jingdong? Look,
Let me check.
check again. 8.1 times pi all over 180.
How much is it?
I cannot see the
80
answer.
or 80?
Same wrong answer.
Oh,
You got this answer.
8.1.
Multiply pi.
Okay.
two answers.
Pi. Oh, pi. Not
Pi.
pi square.
No, pi.
Sorry.
Is that the problem?
Yes.
Okay, so the angle is 0.41 radians. So that if you want to be very proper about it, the tension equals 19.6 times cos 0.141, and your calculator is in what mode here?
Radian.
Radians. But like I said, if you want to leave it in degrees, that's fine, but you'll have to change your calculator in degree mode, and I don't like you using degrees for this, because what did we say at the very beginning of this class? We said 2 things about theta. What are they? Theta is small,
And
and theta is in
radian.
radians.
But how do you know it in the exam if it was in radian?
Yeah, look, if I write this, or if I write this, which is degree and which is radian?
And the left is
degree, and this is radian. How do you know?
The small circle.
Yeah. If this is here, it's degrees. If it's absent, it's radians. Okay? Right, okay, that's enough with that. So I want you to try this worksheet for a few minutes, okay? No. Sorry. All right.